All right, where did I put that? Good grief. I can't find anything in here. I don't know. Oh, crap. What you see here is the ASCII table. ASCII is an acronym. It stands for the American Standard Code for Information Interchange. This was developed back in 1963, and the year after I was born, and the world was very different back then. Computers were a thing, but they were not nearly as big a thing as they are now. We still used binary to encode things, but one of the considerations that was done in the development of the ASCII table was teletype. Do you know what teletype is? Well, maybe if you're a historian of science or something, you know what teletype is. A lot of people don't. Okay, but all of that having been said, that this table had some things in it that don't make any sense anymore. The first two columns are control characters. Okay, and so one or two of them might be useful to us these days, but I'm just going to say ignore the first two columns until we get down to the third column. Okay, now how do I know this is the third column? Because it's labeled with a 3 at the top. Well, it's not a 3. We start counting 0, 1, 2. It's labeled with a 2 at the top. That's binary 2. This is binary 3, this is binary 4, this is binary 5, this is binary 6, this is binary 7. Okay, but we have 8 columns because we start counting at 0. Okay, now the first entry here, it looks like nothing, but it's a very important character. It's a space. Okay. The introduction of spaces between words was a big deal. When the Bible was written, they didn't put spaces between words. Okay, everything just went together, and so when we came with a space, it was a big deal. And so I think it's fitting that they give space the position as the first character. Okay. There is order here. Okay, we have this first column. This is the first column of characters beginning with space and having all of this other special characters in it, because we reserve the top of the column designated with 3, or our fourth column. We start with 0. Okay. And then we go 1, 2, 3 down through here, there, and I'll show you why that's good here in a minute. Then we start at the next column with the @ sign, and then alphabetic capital A. We finish our capital characters through the next through columns, through these 2 columns. And then we don't immediately start with a lowercase a. We pad this out with special characters. We go up to the top of that column and then go down 1 by putting the lowercase characters here. And then we put our lowercase characters through these 2 columns and then pad it out with special characters again. Okay. Now, I'm going to show you something that these are associated with numbers. How exactly? Well, this table is designed to make associating binary numbers with this easy. Let's start again with the space. We'll say space. Okay. In binary, the first four bits of it are 0, 0, 1, 0. I get that from the column heading. And then the last four characters are the row heading 0, 0, 0, 0. Okay, and I'm putting that underscore there to separate the row heading from the column heading from the row heading. And so what number is this? Well, this is the ones place, 2, 4, 8, 16, 32. So space is at 32 in base 10. Okay. Now let's go over and look at 0. Okay, the 0 character. And again, this is a 0 character, not the 0 number. Okay, we make an important distinction there. The 0 character as opposed to the 0 number. It is in column with a heading of 3, so which is 0, 0, 1, 0, underscore, excuse, and I goofed there, 0, 0, 1, 1, okay. And then it is in 0, 0, 0, 0. So I go again 1 place, 2 place, 4 place, 8 place, 16, 32. So if I take 32 plus 16, that is equal to 48 base 10. And so the code, okay, for the number 0, okay, excuse me, the character 0, it's very easy to do that, is 48. Now, let's look at another character, the character for the number 9, okay. It's in the same column, so 0, 0, 1, 1. It's in a different row. It is in the row that is led with 1, 0, 0, 1. Okay, and so we have 1, and then 2, 4, 8, 16, and 32. So I would do 32 plus 8 because the math is easy. That gives me 40. I take 40 plus 16, that gives me 56. And then I add the 1 to it, and so I have 57 base 10. Now, I want you to notice something here. If I were to take 9 and add it to the ASCII code for 0, 48, that would give me 57 again. So if you remember that 48 is the ASCII code for 0, you can recover all of your ASCII codes for the digits just by adding that digit to 48. Yeah, who is it? No, I'm not doing anything. Come on in.